So let me share my screen. If you can see the screen, say yes. If you cannot, say no. So can everybody see the screen? Yes, okay. That's good. All right. So let's start. So today we are going to be working with quadratic equations again. I'm going to teach you another way to solve quadratic equations because last time we solved it using factoring. This one is, sometimes more efficient. Okay, so what if you cannot factor? What if you just, it's not factorable? What do you do now? Then you will have to use the quadratic formula, which we will learn today and we'll also try to prove. Okay, so let's first go over the schedule. Gonna go over some review problems. Gonna review how to solve by factoring, and then we're going to introduce the quadratic formula. So first, let's start with this review problem. Remember, 0 has to be on one side by itself, so make sure you move, this term to this other side here. Okay, give you a couple moments to do that. Okay, so let's go over this. All right. So what we need to do first is we need to move, 15 to the other side. We're gonna, plus 15 here is equal to 0. We must have 0 to factor because we need to use the zero product property. So if we factor this, we need to find the factors of 15 that add up to 8, which are conveniently 5 and 3. So n plus 5 times n plus 3 is equal to 0, right? Because we can factor it like this, right? N plus 5 and then n plus 3. These two add up to 8, and they also multiply to 15. So the factors of 15 that add up to 8. So the factors of C, which add up to B. Okay, so then this one is just going to be equal to -3 and -5, because you remember here, you have to set n plus 5 is equal to 0, n plus 3 is equal to 0. Here you get -5, here you get -3. Okay, next one. Okay, so let's over this. Okay, so we need to what? Move the 5 to the other side, right? What is this? -12, right? So -12 is equal to 0. We need to find a way to have the factors of 3 on one side and factors of -12 on one side and have them add up to basically, we need them to add up to 16, right? -16. So this works. So we have the factors of 3, so that's 1 and 3. The factors of -12 here, so -12 here. And we have -6 and 2, so as you can see, when you cross multiply, you get 3 times -6, and 1 times 2, which is equal to -16. So that works. Once it works, we can just take r minus 6, we go from the top parallel like this, and then 3r plus 2, like so. We get r is equal to 6, and r is equal to -2/3. Okay? Like that. Are there any questions here? All right. If there are no questions, let's keep going here. So again, 35k squared minus 22k is equal to 3. Make sure you do that. Actually, no. Plus 3 is equal to 0. And this should be correct. So you can start from here. Remember, the 0 always has to be on its own side. All right, so let's go over this one. All right, so we have the A term here, the C term here, B term here. Take the factors of A. Let's just go 7 and 5 and 7 for now. Let's try get the factors of 3. So let's just say, 3, 1 here. Okay, so notice how, we have positive 3, but we have negative b. So one of them, of course, is going to be negative terms, right? So let's just say negative 3 and negative 1 here. All right, so we're going to have, let's see here, we can have if you take 7 times negative 3, we have negative 21, and then 5 times negative 1, we have, what, negative 26? That doesn't work. So if we actually just switch these, if we switch these work now. So 5 times negative 3 is negative 15, 7 times negative 1 is negative 7. Add those together, you get negative 22. The factored form of this is 7k minus 3, 5k minus 1 is equal to 0. K is equal to 3/7 and 1/5. So obviously, because 7k minus 3 is equal to 0 and 5k minus 1 is equal to 0, then you solve for k, and it is 3/7 and 1/5. So that is how you factor it. Again, reviewing. Okay. So now we have this one, which we don't actually need to do much factoring here. Factor out the x, 7x plus 2 is equal to 0. X is equal to 0. 7x plus 2 is equal to 0. So x is equal to 0. And also x is equal to negative 2/7. Okay. Like this, because you set this one to 0 and you solve for x, and it is pretty clear. Last one here. All right, so I'll give you a few moments to do this one. Okay, so let's go over this one. So you need to move the 59x to the other side. So here we are. A is equal to 8, B is equal to 59, C is equal to 21. Let's find the factors of A. Let's say 2 and 4 first. We can try those first. And then next, find the factors of C. Let's just say 7 and 3. Okay, so clearly this doesn't work, right? Because if we cross multiply, we get 4 times 7, which is 28 plus 6. That is not equal to 59. So actually, we can change the factors here. If we do 8 and 1 here, so then 8 times 7 is equal to 56, plus 3 is equal to 59. So these work. After they work, we just go the top row and the bottom row like this, and we can factor them like so. x is equal to -7, and then -3/8. Any questions so far? Any questions? If there are no questions, then I will continue here. So let's again talk about zero product property. When you have a times b is equal to 0, that means either a is equal to 0, b is equal to 0, or a and b are equal to 0. Okay. So this works with quadratic equations because when you have ax squared plus bx plus c, is equal to 0, you're going to factor them, and then you get factors. And you can set each of those factors equal to 0 to find, answers, multiple of them. So when you have a quadratic equation, make sure you're getting two answers most of the time. Most of the time, it should be two answers, okay, because you have two factors, right? So let's just give you the general form, right? So A1, A2, C1, C2 are just factors of A and C. They need to add up, okay? A1 times C2 plus C1 times A2 times C1, that must be equal to B, okay? They have to add up to the B term. And once you add up to the B term, once you find the correct factors and the ordering of them, then you can factor it A1 plus C1, A1x plus C1 times A2x plus C2, right? And that's equal to 0. So from this, zero product property says that A1x plus C1 is equal to 0, and A2x plus C2 is equal to 0. So you're going to have two answers here. X is equal to negative C1 over A1, okay? And the second answer is going to be negative C2 over A2. Okay, so clearly in this problem, it is, negative C2 over A2, right? It works like that. Okay, so that is just the general form of solving with factoring. We've gone over it a lot last time. So hopefully you're quite comfortable with factoring as of now. You can factor some more complex quadratic equations, maybe some polynomials, you can factor them. Of course, the most you're going to factor in Algebra 1 is just going to be quadratics. But if you take my higher level course on Algebra 2, then you can factor all types of things. You can factor, x to the fifth if it is factorable, right? And you need some additional theorems for that. Okay. Otherwise, let's move on to what we really want to do today, which is to introduce the quadratic equation. So the quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So this is a very, looks kind of ugly, right? But it's very useful sometimes when something is not factorable. So let me just give you an example of what we can do. So let's just take this problem. Actually, let's take, what is a good problem to take? Something that has, whole numbers. Okay, so let's just take n squared plus 8n plus 15 is equal to 0. Of course, we can factor this, right? I'll just write it in x. Just, x squared plus 8x plus 15 is equal to 0. Of course, you can factor this, but we're going to use the quadratic formula for this. So x is going to be equal to, let's just write our terms here. A is equal to 1, b is equal to 8, and c is equal to 15. So x is going to be equal to negative b, which is negative 8, plus or minus the square root of b squared, which is 64, minus 4 times the a term, which is 1, then times the c term, which is 15, over 2 times a, which is 1 again. So we get negative 8 plus or minus the square root of 64 minus 60 is 4. Just do that. And that's over 2. So you get negative 8 plus or minus 2 over 2. So we either get negative 8 plus 2, which is negative 6, or we get negative 8 minus 2, which is negative 10 over 2, which is, over 2 here, and we get negative 3 or negative 5. So that's very, very helpful, right? There's not really much thinking involved, really, because you take the formula, you have the a, b, and c terms, plug it into the formula, and you're done. And you get this exact answer as you did, like, look at these answers, exact same. Okay, you just plug in this stuff, okay? Plug in this to this formula, and here you get the exact same answers, and it's very helpful for higher level equations where you can't really factor them. They're not factorable. And of course, some equations are just not factorable. Okay, but I still recommend that you use factoring when possible because it is the fastest solution. If you, do quadratic formula, maybe you make a mistake when you're, calculating. So that's not good. By the way, if you do not know, plus or minus is just plus or minus. So this is going to give you the two terms, right? This is going to give you the two terms, right? Because you either add square root of b squared minus 4ac or you subtract. So that gives you two terms. So are there any questions on this? Any questions? Okay, so let me just, ask a question real quick. So if you were to have an equation, right? And there's no correct answer for this. All right, it's just your opinion. I want everybody to write in the chat if there is an equation that you can solve using either quadratic equation or factoring, which one would you prefer? Especially after seeing this new way. Okay, so what would you prefer using? So put in the chat, what would you prefer using? Let me just see your opinions on this. Would you rather factor it and solve by factoring, or would you rather, use quadratic equation, right? I think most people like factoring, right? Because with this quadratic equation, you have to plug it in, and it seems very annoying, right? It is very annoying. It is. So that's good that most people would prefer factoring, but quadratic formula you must use if you cannot factor. So how are we actually going to prove the quadratic formula? Like how do we get here? How do we even get here? Like you get this equation. How do we even go from this equation ax squared plus bx plus c to this quadratic formula? So on this next slide, if you don't want to write this down, don't write it down. This is higher level, right? Higher level proof. You probably if you don't understand it, that's okay. But try to pay attention and follow along. If you are interested and you want to write it down, please do write it down, since this is usually the proof of the quadratic formula. And I don't know, usually the school teachers in school, they will not show this to you. Okay, so we can do this by completing the square. So what is completing the square? Let me just remind you what a square is. So x plus 1 squared is equal to x squared plus 2x plus 1, except now we're going from this back to this. So if you have x squared plus 2x, and you want to complete the square, have a little blank here. Complete the square, you have to add 1. That's equal to x plus 1 squared. Okay, so that's completing the square. Let me give you the more general formula for completing the square. When you have let's just look at a pattern real quick. So what is this? X plus 1 squared is equal to x squared plus 2x plus 1. X plus 2 squared is equal to x squared plus 4x plus 4. X plus 3 squared is equal to x squared plus 6x plus 9. X plus 4 squared is equal to x squared plus 8x plus 16. So hopefully we can find a pattern here. So what we need to do is, when we have x squared plus bx, to find the constant term. So usually we're going to add the constant term to complete the square, right? As you can see, we're going to take the b term here. We're going to take the b term here, and we're going to divide it by 2. And then the constant is going to be squared that. So as you can see, our b term is 8. We're going to divide that by 2 to get 4, square it, and get 16. See here, what is the 2 divided by 2 is 1. Square it, you get 1. Okay? This one, 4 divided by 2, squared is equal to 4. All right, this one, 6 divided by 2 is 3, squared is equal to 9. That's what we do here. So this term is actually going to be b over 2 squared, and that's going to be the constant. All right, so now that we know what completing the square is, let's try and prove the quadratic formula by solving for x. Okay, so what do I mean by this? So we have ax squared plus bx plus c is equal to 0. All right, so you can't complete the square with an a that is greater than 1, right? So you have 2x plus, let's say 8x. Okay, you can't complete it with a here, so you have to divide everything by a. So okay, so let's just divide everything by a. X squared plus 4x. Now you can plus 4 now, and you can complete the square, right? Right. So you have to divide the a first to make sure that it's just x squared. So we have to divide a on everything. Okay, so a everything. Obviously, we get x squared plus b over ax plus c over a. Okay? So the thing is, now, well, we don't really, sometimes we have a c term, but we don't know if it adds up to the square, right? So let me just give you an example here. So x squared plus 4x plus 3, right? This doesn't add up to, the square, which is x squared plus 4x plus 4. So in this case, move this to the other side to get x squared plus 4x, just x squared plus 4x is equal to -3. And then you can, add your 4 here and then complete the square. So the general formula completing the square, this is a general algorithm. You have to take this constant, you move it to the other side, x squared plus b over ax is equal to -c over a. So after that, what is the next step of completing the square? You have to find the constant, right? So that's why I showed you the pattern from earlier. The constant is basically equal to b over a and then over 2 squared. So this is just b over 2a squared, right? This is just b over 2a squared. So after you get b over 2a squared, and this is equal to -c over a. But since we added b over 2a squared on this side, we also have to add b over 2a squared on this side, right? Obviously, because we're keeping the same, right? And once we get b over 2a squared, this is a valid square now. We can just say x plus b over 2a squared. This is what you're going to get. All right? And then you have -c over a plus b over 2a squared. Okay, so here is the important step. Remember that when you take this square root of an x squared, you get the absolute value of x is equal to plus or minus x. Okay, oh, in this case, plus or minus x, not always, but remember this part. Okay, so then you go here and you square root this, square root both sides, right? square root both sides. Once you square root both sides, you get absolute value of x plus b over 2a, b over 2a, okay, is equal to square root of negative c over a plus b over 2a squared. Okay, so actually, before we do that step, let's just have another step here. Let's just simplify negative c over 2a here. So this is negative c over 2a plus b squared over 4a squared. So if you combine this, we get negative 4a squared c plus ab squared over 4a cubed, which is equal to b squared minus 4ac over 4a. Okay, so after we do that, 4a squared, this goes into here. This is this. Okay, this goes into here. B squared minus 4ac over 4a squared. And of course, x plus b over 2a. And since we're taking the absolute value, let's unwrap it. So that's plus or minus square root of b squared minus 4ac over 2a. Move this b over 2a to the other side. We get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. This is the quadratic formula after proving with completing the square. This is it. Okay, as you can see, that is the proof of the quadratic formula. We can derive it by solving for x, like so. All right. So are there any questions on this? It is totally fine if you don't really understand it, but hopefully you followed along and understood like part of it at least. This is higher level than what we're doing. Okay, any questions? Who is that? Okay. Anyways, let's continue now to some practice problems. So for these, you can use either factoring or quadratic formula. So make sure you do that. Which one works best? All right. If it is factorable, obviously use factoring because it's just much faster. If it is not, then you have to use the quadratic formula. Okay, so let's go over this one. Okay, so I think everybody got some different answers. So let's see what this is. Okay, so remember, move all the things to one side and leave 0 on the other. Okay, this is not factorable, unfortunately. Um, I think so, is it? Let's
No.
see. Apparently it is factorable. Okay, so you have 2, 2, 1, 3 on this side. Okay, so and then 2 times 3 is 6, 1 times 2 is 8. You get 2b plus 1 times 2b plus 3 is equal to, which is equal to 8. So yeah. So b is equal to -1/2 and then -3/2. So are there any questions on this? I think Danny got it correct. That's good. Okay, so next one. Okay, so let's go over this one. So Danny says there's no solution. Yuchen says 3 and 1/4. So let's see which one. So we add here, so this like this. Okay, so I don't know. Let's see what we have here. So I don't think we can actually factor this one. Yeah, so the best we can get is, just -5, so we can factor this. Cannot. So we have to use quadratic formula. A is equal to 2, B is equal to -7, C is equal to -3, M is equal to -7, or negative B, which is just +7, square root of 49 minus 4 times 2AC, -4, minus 4 times 2, and then -3 here. It's 2AC over 2 times 2, right? So actually, we're going to be adding here. So this 49 plus something, right? This plus 24, and that's over 4. So this will be 73, and this 4. So I'm fine if you just leave your answer like this, since we don't really know how to simplify this radical. And I don't really feel like doing the decimals, right? Because decimals are not the best thing in the world. I think this should be correct, right? Because we have two negatives here. We are adding the 4AC. So 49 plus all this, which is 24. So that's 73. 7 plus or minus the square root of 73 over 4. You'll get these ugly answers like this, especially when it's not factorable. Okay. Let's move on to the last one. Okay. Last one. Let's see. So let's move the 3k squared to the other side. So 4k squared. Okay, these cancel out. You have negative negative 25 here is equal to 0, right? Because the negative 2k just cancels out, right? And then you have 4k squared, and then you have negative 25 here. This is actually difference of squares here, so we can factor this like this. So if you got plus or minus 5/2, you almost got it. So Disney, you almost got it, and Yu-Chen, you're also very close. You just, I think you just divided 4 instead of 2, but that's pretty close. So I think that's good. It's just difference of squares. Okay, when you have two squares, you can just x plus a, x minus a is equal to x squared, s squared minus a squared. So you have to recognize that these are squares. Then we can use difference of squares. And that is all for today. All right. So I'll see you guys next time. All right.
All right, thanks.